In this video, we're going to learn about something called scientific notation. Scientific notation is the way that scientists like to write very large or very small numbers in a way that makes the math a little bit easier for them. The way that it works is we start with a very large number. Let's take the population of the United States as an example. In the United States, there are approximately 300 million people. Now, if you notice, that's a lot of digits there. Putting this into the calculator over and over again could be kind of cumbersome. So what scientists do is they take the decimal place and they move it over to the first digit. So 1, 2, 3, 4, 5, 6, 7, 8 places over to the left. So that ended up giving a value of 3. But we did move it over to the left 8 places, so we need to make sure that it can expand out to be the same. Well, we write that as times 10 to the 8th, because there were 8 jumps. 1, 2, 3, 4, 5, 6, 7, 8. There were 8 jumps. So 3 times 10 to the 8 is the same as 300 million people. And you can prove that because every time you multiply something by 10, you add a 0 to the end of that number. So if we were to expand this out, we would take our 3, and then we would jump over to the right 8 times, or take that invisible decimal right here and jump it over 1, 2, 3, 4, 5, 6, 7, 8 places. Then, of course, we would need to fill in all those troughs with zeros. So we fill those in. 1, 2, 3, 4, 5, 6, 7, 8. And we end up with our original value of 300 million. So that's the gist of how scientific notation works for large numbers. It works just the opposite for small numbers, and I'll show you that right here. Say we were given a small number to work with, like 0.000051. Well, if we're going to be doing math like this, our numbers are going to get very small very quickly. So what we do is we take the decimal place and we move it over to the first non-zero digit, right there. Then we count how many times we bump that over. So that was 1, 2, 3, 4, 5 places. So our answer would be 5.1 times 10 to the negative 5 places. Now, this is a negative number because the number that we converted it from is very small. If you remember from your exponent laws, that's the same as saying 5.1 times 1 to the over the 10 to the 5th. So that would be a very small fraction that we would be multiplying it to. But that's not how we write scientific notation, so I'm just going to erase that. Okay, if we wanted to take a small number and make it big, we do the exact opposite. We write down our 5.1, and we're simply going to take our decimal place and hop it over 5 times. So 1, 2, 3, 4, 5. And like we did the last time, we're just going to fill it in with zeros. That's 1, 2, 3, 4. So that means we have 1, 2, 3, 4, 5 jumps, and we're back to where we started. As you can see, writing it like 5.1 times 10 to the negative 5th actually makes it easier to see, easier to look at. So that is the gist of how scientific notation works. In the next video, we'll look at some examples. This example is asking us to take this very, very small number and convert it into scientific notation. So something times 10 to the something. So the way we do this is first we find our decimal place, And then we look for where the first non-zero digit is. In other words, the first digit that is not a zero. Then we take our decimal place and we start jumping over. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we jumped over 9 places. Okay. All right. Now we write down the number 9.7. So 9.7. And we need to be able to shrink this number, so we write times 10 to the negative 9, because there were negative 9. There's 9 places over to the right. So that's all there is to it. We simply find where the first non-zero digit is, and we jump all the way over until we hit it. The number of times that we had to jump, in this case 9 times, that becomes our negative exponent. And if you needed to convert it back, you would just hop 9 places over that way, and you'd be back to where you started. In this example, we're going to take this very large number and convert it into scientific notation. Now, one of the great things with scientific notation is that we get to forget about a lot of digits. All these digits right here, we don't need to worry about. We're just going to round them up. So, we're going to start like we normally did. We're going to take our decimal place and move it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places over. So we jumped 13 times. Now I'm going to rewrite the number, but I'm only going to keep the first 2 digits. Now, depending on what it asks you for in the problem, or however many significant figures have, you may need to keep more or less. In this case, I'm just going to keep the 7.4, and because we need to expand it by the 10 to the power of 13, I add that in. So we've taken this very, very large number here and converted it into something much more readable. And it's much more beautiful to look at. Now, if you needed to take this number and convert it back into regular notation or standard notation, you would simply take your 7.4 and move the decimal place to the right 13 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And fill in the rest with zeros. You can probably tell already that our number that we started with and the number that we ended with, if we expanded it out, isn't the same. But fortunately, standard notation contains a lot of digits that we really just don't need to use in real life. So we turn to the scientific notation, which gives us a much simpler way of writing it. That's the video for today. I hope it's helped you guys out. Be sure to subscribe and check out our other videos.